Hello and welcome to section 10.5b. We're going to do a little bit of distance formula. I really should take off this and midpoint because let's do and midpoint with 10.5c. So we're going to find the distance between 2 points on a coordinate plane and actually on a line, number line as well. So number line's super easy. We can figure that out, but we should talk about it. So I wanted to do a quick Pythag review because on a coordinate plane, you can use Pythag or the distance formula to find the distance between 2 points. So quick Pythag review, it only works for right triangles. We know it's right because we've got the right angle mark. A and B are legs that form the right angle. So this doesn't matter which one's A and which one's B, as long as they're the two sides that come together to form the right angle. C is the hypotenuse. And last but not least, the Pythagorean theorem, in case you can't see it, is a squared plus b squared equals c squared. So let's do a little quick problem here, and let's use Pythag to find the distance between K and L. So I put a little coordinate plane on here. K is at -2, 0. L is at 1, 4. And I want to find out what is the distance in a straight line between those 2 points. It's not easy to count, right? Because it's all diagonal. If it were nice and neat in either horizontal or vertical, we could tell. But if we take those 2 points and we draw in a nice right triangle, and we know it's a right triangle because I went directly down from L and directly right from K. So I've got a nice neat corner there at 1, 0. Now, could you tell me the legs of the length of the legs of the triangle? Well, from K, let's name this one M right here. So from K to M, what is that length? 1, 2, looks like 3 units wide. From M to L, what's the height of that triangle? Looks like 4 units tall. And this is our missing part that we want to know, right? That's our C, or our hypotenuse. So we can do Pythag, a squared plus b squared equals c squared. And we would have 3 squared plus 4 squared. Remember, it doesn't matter which order. You could have 4 squared plus c squared. No, you have 4 squared plus 3 squared equals c squared. Or you could use an x, or you could use whatever letter you like. 3 squared is 9, plus 4 squared is 16. 9 plus 16 is 25. We all know how to get to the c because we don't care what c squared is. Let's square root that guy. And we got a nice neat answer this time, right? Square root of 25 is 5. So the length between K and L is 5 units. We can't count it because our grid marks are all diagonal and crazy. So we have to count on Pythag to find that. Does that make sense to everybody? So I'm going to skip this one. Let's talk now. Whoops, I went the wrong way. Let's talk now about the distance formula. So distance formula is another option to find the distance between 2 points on a coordinate plane. So the distance formula, this is a long one. Make sure you write it down accurately with all the right signs. D stands for distance. The square root, giant square root. So we're going to do all the math underneath, and we're going to square root last. In parentheses, I'm going to subtract x's, x2 minus x1, and square it. Plus, the second parentheses, I'm going to subtract the y's, y2 minus y1, and square it. Notice the x1s and x2s and y1s and y2s come from the actual ordered pairs. My first point will be x1 and y1. It's an x and a y from my first point. My second point will be x2 and y2 because it's the x and y from my second point. So just watch those, label them. That's where people make mistakes, is they get in a hurry and they get sloppy. So just be careful on that. And let's do a problem. So let's do this one. This is actually the same problem as the one we just skipped. Whoa, I thought I had it figured out. I just wanted to paste the Pythagorean theorem. There it is. Okay. So if we want to find the distance between the points, -5, 6, and 3, 2, I want to find that distance. We could draw in a triangle and we could do Pythag. Some people like that way. Or we could use the distance formula. So my first point, I'm going to call it -5, 6. So I'm going to call that x and y 1 and 1. My second point is 3, 2. So I'm going to call that x and y 2 and 2. So now I'm going to use the distance formula. D equals giant square root. I'm writing this close to this so that we can use this as a guide. So I've got a set of parentheses squared with x2 minus x1. Well, what's my x2 value? 3 minus, what's my x1 value? -5. You know I'm going to ask you what's going to happen with the minus and the negative? They cancel out, become a positive, right? My second set of parentheses has y2 minus y1. So what's my y2 value? 2 minus, what's my y value? Y1 value is 6. So now I've got a math problem to do. So my math problem is all this stuff underneath the radical. What's 3 plus a positive 5? What's 2 minus a 6? Remember, whenever you square a negative, what kind of sign are you going to get for your answer? Yep, it'll be a positive. So D equals the square root of 64 plus 16. Well, we're going to have to go to our calculators to actually do that math. 64 plus 16 comes out to 80. Got confused. We could break that down. If I asked for an exact answer, that's like a 16 times 5. So 4 roots of 5. If I ask for a rounded answer, I'm just going to go to my calculator. I'm going to type in the square root of 80. Well, the square root of 80 should come out to 8.9 when I round it. I rounded to the nearest tenth, one number after the decimal. So that's distance formula. We could have done the same thing using Pythag, and we would have got the same answer, 4 roots of 5, or 8.9 approximately. Whoops, my board's all messed up. So let's do, should we do one more example? Actually, no, let's go to, hopefully you got this distance formula down. So number 5, notice I asked you to find the distance between -7, 0 and 5, 9. And then I say at the bottom of this page, from here on out, you can use Pythagorean theorem or the distance formula, whichever one you get best. Typically, if you're graphing them, I think Pythag's easier. If I'm just given ordered pairs like number 5 up here, I think distance formula is easier. Let's do this one last example. There's no graph this time. So U is at -7, 0. I'm going to call that my x and y 1 and 1. B is at 5, 9. That's my second set of x's and y's. So distance equals, everybody know the formula at this point? Hopefully you do. There we go. So giant square root. I actually like to do this because then I can just fill in the blank. So what's my x2 minus x1? 5 minus -7, which I know is going to become plus a positive. It's only when they're next to each other. What's my y2 minus y1? 9 minus 0. So now I've just got some math to do. So D equals the square root of, what's 5 plus 7? 12. What is 9 minus 0? So 12 squared is 144. 9 squared is 81. I'm going to do that math problem. 144 plus 81. I don't even know what that comes to. 225? And remember that 225 is still underneath the square root. Just so happens this is a nice, neat number. D equals 15. Forgot my times tables for a second. So the distance between those points was a nice, neat 15. The distance between the last points was a messy 8.9. All right, number line. The distance between 2 points on a number line, it's kind of a funny looking little formula. You take your 2 points A and B, and you subtract them in any order. So if this is a number line and this is point A, this is a number line and this is point B, I subtract them in any order and then take the absolute value. In other words, I drop the sign. So for example, if I want to find BE, looks to me like B is here at -6, E is here at 2. So we could do either -6 minus 2 or 2 minus -6. As long as you keep the sign, that 6 has to be negative. Well, -6 minus 2 is -8. Absolute value of -8 is, remember, absolute value is always how far away from 0 is that number. We don't care which direction. How about over here, 2 minus -6? What is the absolute value of 8? So 8 is my answer either way. On a number line, though, you might have a tendency to count 1, 2, 3, 4, 5, 6, 7, 8 steps away. The distance is just how far in between. It doesn't matter if we're going from B to E or from E to B, as long as you do it one way or the other. All right, so which method of finding distance between points seems easiest? Is Pythag easier for you or distance formula easier for you? And why? My guess would be that you might like Pythag better because you don't have to keep track of x1s and 2s and stuff like that. My other thought might be that you like distance formula better because you don't want to actually graph them. So, two ways of looking at it. And here's 2 points, -1, 4 and +1, -4. Find the distance between those guys. Also, put a little star right at the top by lesson 10.5a, and I'll know that you were paying attention. Have a great day. We'll see you guys next time.